Hi guys, welcome to experiment 17, part 3. Sorry, but this experiment is one that you can't do by yourself at home. And so in this experiment, we're going to be adding a bunch of different substances to water, hydrochloric acid, and sodium hydroxide and see how they react similarly or differently to get a better idea of what acids and bases do. So you've definitely heard of acids before. You've probably never heard of bases before. But by the end of this, we'll have a better idea of what those things are. And so you can't do this at home because hydrochloric acid and sodium hydroxide are dangerous and hard to get. I guess sodium hydroxide is in drain cleaner, so it's not that hard to get, but it's still dangerous. And hydrochloric acid is found in stomach acid, so it's possible to get, but let's not think about that one too much. Okay, so the first substance I'm going to put in these three acids is magnesium metal. And so magnesium is a pretty typical metal. It's shiny, it's silver. And so there it is. Wow, shiny silver pieces of metal. We've actually put magnesium and hydrochloric acid before in this class. And so in case you forgot, here's a refresher. So I put a piece in each of these watch glasses, and then I'm going to put a squirt of water, acid, and sodium hydroxide on each of them. So start with the water. Right? Not really doing anything. Then we put the acid, and immediately we can see bubbles form. It's fizzing, it's moving around. Sorry you can't hear it, but I was just giving notes to myself in the background. You don't want to listen to that. And then sodium hydroxide, I don't have anything. So water, magnesium to do anything. Hydrochloric acid, we clearly have bubbling, and so there is a reaction between the metal and the acid. And then sodium hydroxide, the base, nothing happened. So you can go ahead and record that in data table number 3, and then I'll move on to the next substance. So the next material we're going to test is sodium chloride or table salt. The salt shaker is my proof that I'm not lying to you. Okay, so I'm going to take a little bit of sodium chloride and put it on each of the weighing dishes. I'm going to have to fix weighing dish number 1 for water because I added a little bit too much. Okay, so I'll add some water to dish number 1. Sorry, that's not a weighing dish. That's a watch glass. Watch glass number 1. There we go. Okay, then hydrochloric acid to watch glass number 2. And then finally, some sodium hydroxide to watch glass number 3. Okay, so now let's zoom in and take a look, see what's happening. Okay, so we all know salt dissolves in water, and so if we look closely, we can see most of the salt crystals are gone. There's still a few left, but it takes a while. The same is true of hydrochloric acid. You can still see a bunch of salt crystals, but they dissolve because it's water. And same thing with sodium hydroxide. So the salt dissolved in all 3 of them, but there wasn't any interesting reaction for any of them. So for our next test, we're going to be using cobalt phosphate, or as I like to refer to it, Thanos powder. I didn't come up with the name. Some of my creative freshmen from last year did. And so this is a light purple powder. It's kind of Thanos colored. It's a little bit lighter than Thanos, but it's like pale Thanos. So we'll add some of this powder to each of the watch glasses and then add water, hydrochloric acid, and sodium hydroxide to them, like we did with the magnesium and the sodium chloride. Okay, so when we added water, the water just got cloudy and purple, and so the Thanos powder, the cobalt phosphate, did not dissolve in the water. It just kind of got muddied around. And that'll be kind of our baseline. That's why we're using water at all. Okay, and so the acid, a lot of the Thanos powder disappeared, and then in the sodium hydroxide, it actually changed color. So we'll zoom in on them in a second. But I didn't expect it to change color, so I just kept adding more. Okay, so clearly it didn't dissolve in water, just kind of looks muddy. if you look at the hydrochloric acid, most of it dissolved. And so that's because the acid breaks down the cobalt phosphate more than the water does. And then in the base, it didn't dissolve, but it changed colors. So there was a reaction, just not a reaction like we had with the acid. Okay, so for the next test, we're going to use calcium carbonate or limestone. So calcium carbonate is a little white rock, or I mean, these ones are little. It doesn't have to be little though. And so I'm going to take a piece of calcium carbonate, add it to each of the watch glasses, add the water, acid, and base like normal. Okay, so adding the water doesn't look like it did anything. Adding the acid, if you look closely, there's some small bubbles forming around the edge of the limestone, the calcium carbonate. And the base doesn't look like it's doing anything. Okay, so the water just made the limestone wet, but the acid is reacting with the limestone, and we're getting little bubbles forming around the edges. And then the base isn't doing anything. So for our next test, we'll be using sugar. I have the big jar of sugar in the front just to prove that I'm actually using sugar. I don't know, just in case you guys don't trust me. So add a little bit of sugar to each of the watch glasses like we did before. I did a little bit of a better job with the sugar than the salt, made less of a mess. I realize there's not the same amount on each watch glass. It doesn't really matter. Okay, so we add the water to the sugar, and hopefully you don't even have to watch this to know that the sugar will dissolve in the water. Okay, and then yeah, the acid, the sugar is going to start dissolving because there's water in the acid, and then the same with the base. So now we'll zoom in and see if there were any other reactions. Okay, and so just like we had with the salt, the sugar mostly dissolved in water. Not all the crystals dissolved yet, but that's okay. The sugar dissolved in the acid, and there wasn't any other kind of reaction. And the same is true for the base. Okay. So for our next test, we're going to be looking at butter. So butter is made up of a type of compound called a triacyl glyceride. It's just a bunch of carbons and hydrogens with a handful of oxygens thrown in. So it's definitely nonpolar, like you learned in experiment 15. So putting some on the dishes, sorry, this was a lot more difficult than I thought it was going to be. But I eventually got it. I didn't want to touch the knives to the lab equipment, like keeping food and chemistry stuff separate. Okay, and so based on the fact that butter is nonpolar, we could predict what's happening right now, that the butter is not dissolving in the water. So we can also predict that the butter won't dissolve in the acid or the sodium hydroxide, but there might be some other reaction. Still need to find out about that. Although it doesn't really look like there's any reaction with the acid right now. Then we'll add the base, and it also doesn't look like there's any reaction. And so we don't have any reaction for any of these. So for our next test, we're going to be using universal indicator. So universal indicator is an acid-base indicator. And so we add it to solutions to see if they're acids, bases, or somewhere in between. And so the color of universal indicator changes based on the solution you add it to. So if we add water to it, it gets a little bit lighter, so it looks like we're just diluting it, but it actually changes to kind of a greenish yellow after a few seconds. So it was orange, now it's a greenish yellow. If we add acid to the indicator, then it turns a pinkish color. And if we add sodium hydroxide to the indicator, then it turns blue. Okay, so I'll zoom in so you can get a better idea of what they look like. So our water is kind of a yellowish greenish color. The acid, hydrochloric acid, is a pinkish color, and the sodium hydroxide is a bluish color. Okay, and so now, once you get to the analysis questions at number 5, you're going to look at what happens when you mix acids and bases. So I'm going to add some sodium hydroxide to the hydrochloric acid with indicator in it. So that blue area in the middle is because there's more sodium hydroxide there than the other areas. And the blue area gets larger as I add more sodium hydroxide. And then if I mix the acid and the base together, there's more base now than there is acid, and so the whole thing turns blue. So if I add more acid, then we'll have the opposite effect as long as I add enough. So if I add a little bit more, then the solution will shift to that reddish pinkish color again, and it'll stay there. And so adding a lot of base to acid causes the acid to change to the base color. Adding a lot of acid to base causes the color to change back to the acid color. So for our final test, we're going to be seeing if water, hydrochloric acid, and sodium hydroxide conduct electricity. To do that, we're going to be using that sketchy looking device on the right side of your screen. And so that is my homemade conductivity meter. It's 2 paper clips attached to a 9-volt battery, but it'll work. And so what we're going to do, we're going to put it in the solution. And if bubbles form, then the solution conducts electricity. And so if you look on the left side at the paperclip on the left, there are some bubbles. So that's just pure water. It's not supposed to conduct electricity, but it's not like intensely filtered, so it does a little bit. But we're going to say that doesn't conduct. So now if we put it in hydrochloric acid, there's tons of bubbles being produced at the paperclip on the right and a decent bit on the left. So the hydrochloric acid definitely conducts electricity. And the same is true for the sodium hydroxide. We see a lot of bubbles on both paperclips. And so our acids and bases conduct electricity, but water does not. So now at this point, you should have all the data you need to finish part 3. You can go back through the videos and write down anything that you didn't write down as you were watching. But if you need any help, let me know. And thanks for your patience as you watched me do this procedure. I would have loved for you to have done this at home, but like I said, all these substances are either hard to get, dangerous, or both. And so it seems safer to do it myself. But don't worry, there'll be some more do it at home labs down the road.